Hi guys, so today I'll be doing chapter 2.5, question number 71. And it asks, show that the function f of x at x to the power 4 sine 1 over x if f doesn't equal 0 and 0 if x equals 0 is continuous on negative infinity and infinity. So what this function tells us is at 0 it exists as x equals 0, and everywhere else it exists as x to the power 4 times sine 1 over x. So I looked it up earlier on Google. If you're interested, here it is. Let me zoom out. It basically looks like a vertical line, but so the way zoomed in here, that's what the function looks like. An approximate drawing by me, by my fingers. I don't have a stylus, I have fingers, I have a tablet. So I apologize in advance. This isn't going to be the best quality. Actually, I should tell you something before. If you ever plan on making a screen capture, don't download this software. As you can see, this Malwarebytes I had to get after I downloaded that. It's not the best, even though it's free. It's not the best. Just get the Camtasia, the $200 software, and use their 30-day free trial. All right, so theorem 7. Theorem 7 tells us that this part, the first part of the equation, is continuous on all, if it was just f of x equals x to the power of 4 sine 1 over x, it would be continuous. But we have this little area, this little contention. Well, that's not a highlighter, but you get the point. So what that tells us is here it equals 0, and let's hope that the rest of the function equals 0. And if that happens, let's hope the rest of the function approaches 0. And if that happens, it'll be continuous. So how do we figure that out? If you recall from class, when Professor Turnbull said if it's got the sine or tan, or not tan, sine or cos, you should go to squeeze theorem, because we know sine is in between negative 1 and 1, and cos is in between negative 1 and 1. So here we go, squeeze theorem. So first of all, we'll write out sine. What is that? Is that a smiley face? Just wanted a dot. There we go. Sine 1 over x is between negative 1 and 1. All right, and we change that to negative x to the 4. X to the 4. Oop. Yeah, this tablet, not the best idea, but my phone's camera, come on, my phone's camera broke, so I have to make do. Oh, that one. X to the 4. So we multiplied everything here by x to the 4, and that's what gave us the second part of the equation. And so now all we have to figure out is, do those two bounding? Do these two, do they approach 0? Because if they do, then the inside part approaches 0. I mean, this part will approach 0 if these two approach 0. There we go, that's a bit clearer. Alright, so we'll start drawing. Oh, no, not in red. If x approaches 0, negative x to the 4. Well, relatively easy. It approaches 0. And limit as x approaches 0 for positive x to the 4. Well, that equals 0 as well. And this shows us, let's make some arrows for more clarity, that x to the 4, oh, forgot, limit, as x approaches 0, for x to the 4, sine 1 over x, and that approaches 0 as well. So, using theorem 1, that theorem 1 all the way in the beginning of this chapter, not this chapter, this section, that says f of x as x approaches a, if that equals f of a, then this is continuous. And that's what we just did here. F as x approaches a equals x of f of a. Ooh, that was hard to say. There you go. So then we know that, what do we know then? That this approaches 0 and it's continuous. Let's go all the way back up here. So what that basically does, let's pretend that we're very zoomed in. Let's pretend that this is 1 pixel, or whatever the smallest number would be. Let's pretend that this area is 0. So we know that this is correct based on this part of the equation. So we know that that's correct. And then from here we saw this function approaches 0. So basically, I don't know how mathematically correct this is, but if or not if, well, these functions are joined, so now we know that the total function, the big picture, it will do something like this, and it'll be true on all of those functions, or all of those numbers, and we know it's true at plus infinity and negative infinity. It goes forever. And that tells us that this function is, yes, it is continuous on negative infinity and positive infinity, these two big parts. And that answers the question.